video we will discuss about Rutherford scattering experiment. Before jumping into the Rutherford scattering experiment, we know that electrons and protons are the basic elements of an atom or a molecule, or they are the fundamental particles. But how these particles are arranged inside the atom? So, lot of discoveries are going on to know how they are placed and what should the atom look like. To study that one, Rutherford have done this very famous experiment that is known as Rutherford scattering experiments. So with this, he is able to give us some picture, an approximate picture of atom and how does the atom look like and how these fundamental particles are arranged inside the atom. Now to do that one, so first he has set up this experimental setup. So he has taken this as source, this is a bismuth source, it's an isotope of a bismuth which emit a continuous alpha particles having an energy of approximately 5.5 mega electron volt. And this is your collimated, alpha particle is get collimated, means with this slits we have a very fine beam of alpha particle emitting out and it strikes the screen. This screen is of gold foil and having a thickness of approximately 2.1 into 10 raised to power minus 7 meter. So this is very small or thin gold foil. So these alpha particles get scattered by this gold foil and these scattered particles are observed by this circular screen which is made up of zinc sulfide. This zinc sulfide is a particular type of material which get illuminates when the alpha particles strike on the screen. So by moving a detector over the screen, we can able to know that how many alpha particles would have been strike on the screen. If you see the top view of this arrangement, it will be like this one. So here, this is the source of alpha particle. These are the slits which produces a collimated beam or which produces a fine beam of alpha particle, strikes this gold foil and alpha particle gets scattered all around. And with the help of this detector, we can able to calculate or be able to know that how many alpha particle has been strike on different angles. By placing a detector at a particular different angles, we can find out what are the different particles scattered in different directions. And we draw this observation on the graph. So what is this graph? It is a graph between the scattering angle and the number of the particles scattered. This is our logarithmic graph. Now, here, this angle is known as a scattering angle. So, scattering angle is an angle between the velocity before scattering and after scattering. So, this angle is known as a scattering angle. So, the graph is obtained along this direction. So, what are the observations we got from here? So, first we observed that most of the alpha particles passes on this gold foil without much deviation. Most of the alpha particle passes on this gold foil without much deviation, and approximately 0.14% of the alpha particle have a deviation more than 1 degree angle. Means सिर्फ 0.14% जो पार्टिकल थे वो डेविएट हुए 1 डिग्री एंगल से ज्यादा. इसका मतलब ये हुआ कि 98.86% of the alpha particle passes on without any deviation. The second one is that very few particles deflected more than 90 degree angles, and 1 out of 20,000 particles deflected in a backward direction. So this is your observations we got from this graph. Next thing is what inferences we get from these observations. So first one is most of the alpha particle passes on without much deviation. Means if alpha particle passes on the atom there is no deviation, means no obstacle. It means that most of the space inside the atom is empty. Most of the space inside the atom is empty. Second thing is that only 0.014% of the particle is deflected by more than 1 degree angle. It means that the size of obstacle from which this alpha particle is deviated occupies a very small space. So you can say that the obstacle which is deflecting the alpha particle is of very small in size, or it occupies a very small space inside the atom. The third observation is that if a particle is deflected by more than 90 degree angle, this means that that obstacle must be here. Very few particles, बहुत ही कम particles are deflected by more than 90 degree angle. It means that if a particle is deviated more than 90 degree angle, then it means that that obstacle must be a positively charged. We got that obstacle, whatever it is, that is occupying very small space, is positively charged. Only then the deflection will be more than 90 degree angle. The fourth one is if 1 out of 20,000 of alpha particle get rebound back or reflected back. Now we know that when an object can be rebounded, if suppose you throw a ball on a very soft surface and a light surface, you will find that that object will not be rebound back with the same speed. But if you throw any ball on a very hard surface and massive one, then it will rebound back. For example, if you throw a ball on this wall, which is here, if you throw a ball on this wall, then it will rebound back approximately at the same speed. So from this, we come to the conclusion that the obstacle from where this alpha particle has been rebound back, then that obstacle must be a very hard one and it should be a massive one. So one more thing we get, the obstacle is hard and solid, and second is massive. So these are the inferences we got from this Rutherford scattering experiment.